All right, guys, so today we're going to take some notes over using quadratics to represent projectile motion. Okay, so this link is in the slides, and this is what I'm using to take the notes. However, I still need you guys to take the notes. When we are done taking notes, you're going to take a picture of your notes and upload it to this week's assignment. So I'll go through that once we get there. But first of all, okay, so what we're going to be doing is using quadratics. This is the title for your notes. Quadratics. To model, this is harder than it looks, you guys. To model projectile motion. And you will also be seeing this a lot in physics and getting a little bit more in depth with it, but you'll be using quadratic, so it's good to see it now, using to model projectile motion. Okay, so hopefully by now you have watched all of those videos about the different types of quadratic projectile motion, but we're going to kind of stick with your basic ball gets thrown out of a window on a building and lands on the ground. So there's all different types of things we can find here. So like, so there's my building, there's how high the ball goes up. Oops, let's call that your maximum. Okay, this is how many minutes. Usually we just use minutes, maybe seconds. Actually, let's use seconds. The ball's not going to be in the air for minutes. Okay, we call it seconds. And you can use there's going to be two different equations, one for feet and one for meters. Okay, but these are what projectiles are going to look like. It could be a ball, any sort of ball. They use that a lot in the examples, golf balls, basketballs, whatever type of ball you're looking at. Football would make a nice quadratic when it's thrown. You can also do things like cannonballs, rockets, bullets. And here's the thing, you guys, this looks kind of like, yes, I threw the ball off of this window or roof or patio or whatever, and it's going to go so far and land. But notice that this is seconds. On the x-axis, it is not feet. So even though it looks like this is distance, and I guess time is distance when you think about it, but even though it looks like a specific amount of distance, what we're talking about is seconds. So time is here, and height, the distance that it's going up and down, is on the dependent variable. So what this means is that if you had a gun and you just shot it directly into the air and it came back down, it would still look like this graph, because we are graphing how far up and down it goes over how long it's in the air, even though it's just going to go straight up and straight down. Well, the bullet might not go straight up and straight down. Lots of people get killed by bullets from people just firing them into the air for celebrations. It's very dangerous because things come down just as fast as they go up. If you look at this, and let me switch to a highlighter here. If you kind of look at my little graph, it's going, you can tell faster, 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 that it stops moving, or maybe it gets slower towards the top, then it stops moving, and then it comes down and it gets faster, faster, faster as it goes down. And you can tell by the way that these points are exactly the same distance that it is going the same speed. And we'll get into where speed is in the equation, but for right now, this is your basic little graph that we're going to be looking at for any projectile. So let me go back to the notes that we're going to be using. Oh, look, it did the same little picture over there. So that's cool. Let me pause for 1 second. All right, so here's where we're going to talk a little bit about science. So right here, it's giving us, oh, I can't highlight that. It's giving us our basic equation that you're going to use for feet. But let me tell you where that comes from a little bit. So I'm going to go back to the notes. So really, if something's coming down, gravity, if it's coming down in feet, gravity is negative 32 feet per second. Okay. Or gravity is negative 9.8 meters per second. Okay, so we have two different numbers here, of course, standard that we've been using and metric, which we should be using, but we still use a lot of standard in the US. When I lived in the UK, they had just switched over to standard. They hadn't just done it, but people my age had learned the standard, the feet and inches, and people younger than me had learned like meters and seconds. So when I was trying to ask direction somewhere, I would have to make sure that I found somebody older than me to ask directions to, because they would give me miles instead of kilometers. And it just makes a lot more sense to me still in my head. But the more you use the metric system, the easier it gets. I'm sure that's all you use in science. But this is gravity, right? So this is gravity. This is gravity. We use gravity when we're talking about our equations. So the basic equation that we are going to use is, make sure I write it down correctly, y equals 1/2 a, remember there's our a from just having a quadratic, and then instead of using x's, we use t for, anybody, time t squared plus, and then this one, we're going to write it as v naught, which is going to be our acceleration times time plus y sub 0. Why not? This is your, of course, you know, this is a standard form quadratic equation, right? Standard form, which means that y naught at the end, that y sub 0 is always going to be our y-intercept, or maybe how tall the ball is when it goes up, right? So this is standard form, this should be an R form, or we also call it general form. So if we break this apart, what we do is we get two separate equations. We get one using feet, and we get one equation using meters. And what that's going to look like, let's do a little over here. Our y is going to be our output, or our height, which we already talked about. Okay, our a is going to be our gravity. Or I guess acceleration due to gravity. Acceleration due to gravity. Our v is our velocity. Starting, our initial velocity. That's why we have the sub-zero. And this is our initial height, right? And I don't know if you guys have had physics before, but you might already know all of this information. So, but here's the things that you really need to remember. That's where everything comes from. And there are going to be a lot, when you take the SAT this year, there's going to be a lot of just like projectile questions about the SAT, on the SAT. I would say the majority of looking at quadratic equations is going to be looking at projectile motion equations. Okay, so over here on feet, or at least it has been on tests in the past. I don't want to make a blanket statement there. For feet, if our acceleration due to gravity is negative 32, but look, in our equation, we multiply that half of negative 32 is going to be negative 16. And, you know, let's write this as a function. So h, height, given time, a certain amount of time. So h of t is equal to negative 16 t squared, okay? And then plus your initial accelerating velocity, your initial speed, times t plus your initial height. Okay, and it's going to be the same for meters, except since acceleration due to gravity for meters is negative 9.8, the formula is going to be negative 4.9, because half of negative 9.8 is negative 4.9. Should we put our h of t? Our height given time is equal to negative 4.9 t squared plus our initial velocity, whoops, of t plus our initial height. Okay. So normally what you would see is A, B, C when we're looking at standard form, but here we have an actual value that we got from the acceleration of gravity. And instead of B, we're using V sub 0, and instead of C, we're using Y sub 0. But we know all of this. This is all of the same stuff. Okay. So now that we know this, we can start putting this information back into some questions, right? So if we let's look at here, it gives us some steps, okay? So when it says here, the steps when you're solving projectile motion. I would love for you right now to pause this and write down these steps. I don't want to waste time during this video to do it, but at home you guys can pause this and write them down. Step 1, set the equation equal to the appropriate height. Solve the equation found in step 1 by setting the equation to equal to 0 and factoring. Now, here where it says factoring, we don't have to factor. We have 3 ways that we have learned to solve equations. We have factoring, or we have used the quadratic equation, or completing the square. So there's 3 different ways that you can solve quadratic equations, right? So instead of just factoring, you could use any method to solve quadratic equations, and based on the problem, determine which answers are correct. So question 1, and do not forget to include units in your final answers. And I would say complete sentences also, to prove to me that you really understand what's happening. So let's do this problem. A ball is thrown straight up from the top of a 128-foot tall building with an initial speed of 32 feet per second. Okay, so that, let's see, can I just copy this? And paste it? Oh, I guess not. I guess I cannot do that. But what I am going to do is, and what you should do when you're solving a question, is kind of like every time I run into numbers in a math problem, when I'm first starting one, regardless of whether you need it or not, is I write it down and what it stands for. So a ball is thrown from the top of a 128-foot tall building. So if it's being thrown from the top of a 128-foot building, I'm going to put 128 feet, okay? And that, what does that look like? My dog's making funny noises. In terms of a projectile motion question, this is going to be y sub 0, or as we call it, your initial height. That's the height that we are starting from. So like right away, I grabbed that number and I said what it was, okay? And then it says with an initial speed of 32 feet per second. So it already tells us what our initial speed is, right? So our V sub 0 is 32 feet per second. Okay, the height of the ball as a function can be modeled with the function. Okay, so it even gives us the equation. We don't even have to do that. How long will it take for the ball to hit the ground? Okay, so what we're talking about is the equation that it gave us was exactly what we would have gotten on our own. We know we're using feet. We know we're using feet, so we know we're going to use this equation. And all we have to remember now from that equation is that our initial height, 128, is going to go back into the equation for our initial height. So instead of y sub 0, you're going to have 128. And then let's use pink. I love pink. And then 32 was our initial velocity. So that's going to just substitute back into the equation for v sub 0. Okay, so what does that look like when we actually write the equation out? Is going to be h of t is equal to, and we're using feet, so negative 16 t squared plus our initial speed, 32 feet per second, plus our initial height, 128, right? So something cool about the acceleration of gravity, you can say, I don't know why you guys, but for some reason I think it's so much fun to say. You see how we have t squared here? You can say negative 16 per second per second. And for some reason that just sounds really mathematical to me, per second per second. So instead of saying something squared, you say per second per second. Anyway, what are we trying to find? When does the ball hit the ground? So our output on this side needs to be, what's the height of the ball when it hits the ground? 0. Our output's going to be 0. We want to know how many seconds will it take for the ball to be 0 feet off the ground, okay? So we're gonna solve this as this. T squared plus 32. And they set it up really easy to factor, so we might as well go over it factoring. But you can see we're just trying to find the zeros, find the solutions, find the x-intercepts. There might be 2 because it's a parabola, but only one of them is going to make sense in terms of the problem. So if we're going to factor this, they set it up nicely because 16 can go into 32 and can go into 128, I believe. If I divide 128 by 16, I'm going to get 8. Okay, so what I'm going to do to make this easy to solve, which is probably what they did, is first factor out that negative 16 and just kind of put it on the outside. So if I factor that out, 16, what I'm looking for on the inside is 16 times what will give me negative 16 squared, and that's just going to be t squared is what's left over. Now this is a tricky part. I took out a negative, so what that's going to do is change both of those positives to be negatives. So it's going to be minus 16 can go into 32 twice, minus 2t. So if you didn't understand that, think about it backwards. Negative 16 times negative 2, t will give you positive 32t. Okay, and then this also changes to a negative since I factored that negative out. And how many times did we decide? 8 times. So negative 8. Okay, so it's okay for that 16, that negative 16 just to be hanging out on the outside because it's being multiplied and because we know that anything, if we make our factors 0, that 16 is just going to be zeroed out anyway, right? So now you can go ahead and do your X box. So here's our box. And here's our X, remember this? Now, because there's no number in front of the t squared, or it's just 1, you could just do it in your head, but let's go ahead and review our X box. So we're gonna put the first term, t squared, and the last term, negative 8, diagonal in the box. Okay, then we're gonna multiply the coefficient of t squared, which is just 1 times -8, and we're going to put that in the top of our x. Then we're going to take, so what we're doing is we're trying to fit this trinomial into something that has 4 spaces, okay? But since there's only 3 to start off with, we need to split this middle one into 2 numbers, but we don't know what they are, so we have to figure them out. So we're going to take that -2, we're going to put it here. So what we're trying to find are 2 numbers that multiply to be -8, but add up to be -2. Since they multiply to be a negative, one has to be positive and one has to be negative. And since they add up to be a negative, I know that the bigger value must be negative. I'm going to go with -4 and +2. 2 minus 4 will give you -2, and 2 times -4 will give you -8. So we have -4 and +2. Now we factor along the outside of the box. So what's the biggest number that can go into -4 and -8? That is -4. -4 times what will give you, no, oh, sorry, we forgot to put our t's here. Geez, how many of you guys were yelling at me through the video? -4 times what will give you -4t? That's just t. T times what will give you t squared? That is also just t. And t times what will give you 2t? That's +2. So what this side is t minus 4. And the bottom is t plus 2. 2 for t and t for 2. Okay, and now we just have to figure out what are our 2 answers here. We have to make it equal to 0. So we are trying to figure out what number -4 is 0. So t sub 1 is going to be +4. And here we have what number +2 is equal to 0, and that's going to be t sub 2 is equal to -2, right? So it does cross the x-intercept at 2 places. There are 2 0 values, but in this real world situation, what does t stand for? T stands for the number of seconds, right? It's time. So what really makes sense here? It took -2 seconds to hit the ground, or it took 4 seconds to hit the ground. Obviously, it's going to be 4 seconds. So in a complete sentence, the ball hit the ground at 4 seconds. You know what? I need to use a number there. This is a math problem. It's not an English problem. Although I guess I told you it was a sentence. We should capitalize it. The ball hit the ground at 4 seconds. Why don't we go ahead and find our height, the maximum height of this ball? I don't think the question was asking for it, but it's a little bit more for you guys to put in your notes. So if we have this parabola and the ball was thrown at 128 feet, here's the maximum, right? And we found our 2 zeros. So over here is 4 seconds. That's where it hit the ground there. And the part that made no sense in this problem is over here at 2 seconds, right? So the line I made here is the line of symmetry. That is not the y-axis. Y-axis is the building. It's not the ground, it's seconds, but we tend to do it that way. So seconds is there, and height is here. So the building is the axis. I drew the line of symmetry. So remember, the line of symmetry is going to be right in the middle of -2 and 4. So a quick way to find that is to find the average or the mean of those 2 numbers. So -2 plus 4 divided by 2 should just give us 1. 1 is going to be the mean. or the number, oops, 1 is going to be the number directly in between -2 and 4, right? If I add 3 to 1, I get 4, and if I subtract 3 from 1, I get -2, so it's directly in the middle. So what does that mean? That means that at 1 second is when the ball hits its maximum height. But what is that height? Well, what you can do is you just put it back into, make it as the input of the equation, right? So let's just use our calculator here. I'll take our bottom equation. I think it'll be easier to type in. -16 parenthesis t minus 4. But remember, time is 1. We want to know how tall the building is after 1 second. So I'm going to put 1 minus 4 parenthesis 1 plus 2. If my input is 1 second, what is my output? 144. So what that means is, if we were going to answer that question at what is the height, we'd say the ball reaches a maximum height of 144 feet after 1 second. Cool, so we got both numbers in there. Let's go back to our notes page. Cool, so it gives you an example 2, example 3, and example 4. After you take these notes, if you could please choose 2 more examples just to write down. All of the answers are there. Write it down in your notes. And then tomorrow we will do some, I'll have you do some practice problems. I'll assign some practice problems. That'll be perfect. So just take the notes for now and write down 2 more of these examples. Now, before I get off, when you are done taking your notes, here's what I need you to do. I need you to take a picture of them. And then, hold on one second. The easiest thing to do, you can either send yourself a, in your email, that picture, and you can do this. If you go to, I made myself a student in class, okay? So if you go to your class, and then you go to your classwork, and then you click on the week 2 assignment, right? View assignments. Over here on the side, if you click add, okay, you can add a picture. I just want you to add whatever you want. If you've saved the picture on your computer, you would add it as a file. If it's in your Google Drive, the picture that you just took, you just add it from your Google Drive. You can just add a link. Whatever it feels like to you, add it there. And that should be a picture of the notes that you just took. If instead of using your computer, you would like to use your phone, I have found the Google Classroom very easy to use on your phone. So let's see. If you have, oh no, it's not going to let you see my phone. Okay, let me take my background off here. I have all kinds of virtual backgrounds. None. Okay. If you take your background off, I should be able to show you the phone. Okay. So, oh no, it's backwards to you guys. No, it's not. Okay. So if this is your you've downloaded the app and you open up the class, it looks like this, okay? And at the bottom, I want you to go to classwork. Okay, so I clicked on classwork. Now I'm going to click on the Unit 2 assignment or Week 2 assignment here. Okay, now at the bottom where it just says your work, click that and you can just add a file. So if you download the app and you take a picture with your phone, you can just upload it there using your phone. But either way, I need to have that uploaded to the assignment, added to the assignment. Okay, tomorrow we'll work on some practice problems. Today was just notes. Thanks.